Do it.
There, and I'll switch it so you can actually see what's going out.
Sure. Doesn't matter.
There.
I don't look at it anyway. Oh, we did it.
We
Made
did.
it
We
another
did.
year.
And
Yeah.
yeah.
It's been I've used this as my background for the Weekly Space
Weekly
Hangout,
space.
and this is
Yeah.
and this is like my actual background. And so finally, for the first day in 2 months ish, we're getting a break from the cold weather and snow. Unbelievable. Like everyone again, where we've moved, everyone around us, all my neighbors are just like, this is not normal. But I mean, this is the climate. I mean, this is what a climate catastrophe looks like.
Yeah, that's one of the things people really don't understand is while the average goes up, the variance around that average also goes up.
Yep.
So while it may be 20 degrees above normal one place, it's 19 degrees below normal somewhere else.
Yep. Yeah. That is a climate crisis, and I am sure this is the same experience that we're having. That it just went from brutal heat wave to torrential rainstorm to shockingly cold. Is the new cycle, and so just
we
the
did the same
moderation and
thing
mildness
by way of tornado. You skipped the tornado step.
Yeah, we don't get tornadoes yet. That's clearly next.
Yes.
I think we did have one. Yeah, there was some in Vancouver. So there was some tornadoes out in the water just outside of Vancouver.
That's a water
But they did.
spout.
Yeah. Tornado over the water is a water spout, but it's still a tornado. Still swirling winds looking to destroy things. And these bomb cyclones. And I think we talked about this before that we've got you got the East Coast has a bomb cyclone coming in.
Oh wait, the East Coast?
Mm-hmm. Yeah.
You're not supposed to get those. Only the West Coast is supposed to get those.
Huge, horrible storm coming in on the East Coast of Canada, and I'm sure the Northeast. Yeah. It's been a thing. What else is happening? I hope you've been enjoying James Webb. I know it still doesn't exist. Would you? On Saturday, they will deploy the final little flappies for the primary mirror. They've deployed the radiator. They deployed the secondary mirror.
Actuators work, it's dead to me. It has to have actuators functional. That's where it is for me.
So deploying the secondary mirror the primary mirror doesn't count. You need
actuators so you can focus. It needs to be able to focus.
Right, it needs to telescope.
Yeah,
Okay.
So there's a very specific reason. The Hobby-Eberly telescope in West Texas at McDonald Observatory. I was supposed to use that telescope for the bulk of my PhD. I was supposed to get order of 18 to 30 spectra per galaxy cluster for a couple dozen galaxy clusters.
Yeah.
I got like 6 total spectra.
Right.
And not 6 clusters, 6 spectra. And the reason is that the way they built the telescope initially, they thought that they'd be able to keep it in focus using maths and not edge sensors. And it turns out you can't because chaos. And I learned so much about the importance of actuators and actuators doing the right things.
Okay. So you're really battling...
I'm scarred.
Demons from the past. Yeah.
I am scarred by multi-segmented telescopes. Yes. And by spacecraft not spacecrafting. I had both happen. We've passed one set of difficulties. We're now on to the other.
All right. Then, and so, I mean, we're going to get the full deployment, but then we are probably looking for another couple of months before we make sure those actuators are fully checked out. So, all right. Okay. I mean, you've been patient for 20 years. you can wait another couple of months before you will acknowledge its existence. I'm cool with that.
Yeah, yeah.
Then we will not speak of it again.
We are reporting on it, much to my dismay, over on Daily Space. I
Right.
had to do an update yesterday because Beth was out for the day.
Yeah. Grumble, grumble. Something happened. I don't care. Was that the report?
So you're really close. The Trello notes
Yeah.
for the segment. The Trello notes for the second segment were grumble, grumble, JWST, grumble. It was longer than that when we actually did it during the show, but that was the
Yeah.
Trello card.
Yep. That's awesome.
And my hair
okay.
is in my microphone.
Yeah, I know that problem. All right. Let's get started.
All right. Are you ready to press? Oh, I need to open one more file.
Okay.
I'm actually going to remember to open up the Patreon stuff before we need it at the very end of the show.
Nice.
I'm learning. It's only taken me 15 years. And I'll even move them onto a screen where I can see them without looking all over the place. There we go. All right. We ready to do this thing?
Yep.
Can you get any taller in your chair?
No.
All right. I shall slump.
Or just shift me down a little bit.
Let me actually
need more
just.
headspace?
I was just trying to make us look like we were proportionally scaled. Currently, you have a giant head.
Mm-hmm. I mean, I can make myself smaller and sure.
Yeah, but then you end up floating weird. Let me see what I can do. Yeah. Okay, it's as good as it's gonna get. It's fine.
All right.
It's fine.
Okay, it's fine. It's fine. I think you're being overly cautious.
I'm just giving you a giant head. That's all.
Well, I already have one. Okay. Let us begin. I'm going to press record.
Yeah. All right. I've pressed record.
Okay, great. Astronomy Cast, episode 626, the terrestrial planets, Mercury, Venus, Earth, and Mars. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am cold. In my studio, it is 18 degrees Celsius. It's in the 60s inside the house, because outside, we're in the negative numbers, and our house needs new windows.
We should at least acknowledge, I know you don't want to talk about it, but there exists a telescope called James Webb, and things seem to be happening to this telescope. That's all I think Pamela is willing to talk about this week. Maybe in future weeks, we will go into greater detail. But until it is fully deployed, it is a telescope that shall not be named. So I've already enraged her bringing this up. brought forward deep-seated emotional scars, and now she's gonna need probably a nice stiff drink afterwards to get over the anxiety. But we're just another week or two, and we're fully deployed, and then we move into the testing of phase. Anyway, I'm not going to talk about it anymore. The thing that I do want to talk about is that we are looking to bring on more of the science communicators for the Weekly Space Hangout crew. The Weekly Space Hangout. And of course, this is the show that we do every Wednesday. It's like a roundtable of a variety of space science communicators. Some are practicing astronomers, some are PhD graduates, some are space journalists like me. And we rotate through this group of people, and we've got a bunch of slots open up. And the person that this is perfect for is someone who wants more practice, or wants any kind of practice in doing live science communication. If you just want to build your chops in communicating either your ideas or just science ideas in general to a wide audience in a fairly, I feel like it's a fairly forgiving and non-hostile environment, and it's really a place for you to get training. And so if you feel like there's just not a lot of places for you to get practice, and this is a field that you want to do or skills that you want to add, then we would love to have you join us at the weekly Space Hangout and be one of our journalists every week. So send an email to Nancy Graziano, WSHcrew1 at gmail.com, or you can just go to the website and there'll be information there, and let her know that you're interested, and then tell her your info and what you're looking to get out of it. And we would love to have you join us. So that's it. Let's move on to the show. We continue our refreshed tour of the solar system, checking in on the interterrestrial planets, Mercury, Venus, Earth, and Mars. What have we learned about their formation, evolution, and what they might tell us about planets across the universe? And we will talk about that in a second. But first, it's time for a break. And we're back. All right. Where do you want to go with this? How should we start? I mean, it's been, I don't know, 10 years, 12 years since we've talked about the inner solar system. So it makes sense to have another crack at it.
And what I love is in the Trello notes for this show, I had omitted Mercury to put Mercury in the next episode when we're talking about other things that are super close to the sun.
But so it's not a terrestrial planet?
Well, it's a big old rock. And so when you look at the histories of Mars, of Venus, of Earth, all three of these worlds, for their first 3 billion years or so, were experiencing the great heavy bombardment and had liquid oceans and have had tectonic episodes and continue to have geophysical activity that alters the face of the planet. And little Mercury is literally off screen in the image that will not let me drag it. It's literally off screen. It's not even on this image, in fact. I thought it was off screen. And the thing is that because it's small, because it's unusually dense, because it has an ion tail, the geophysics of Mercury are radically different than what we see with these three larger worlds.
Okay, well, we'll cover Mercury more next week, but let's focus then on the larger and farther planets, Venus, Earth, and Mars. If you were to sort of characterize them in their togetherness, what would you define them? How would you define them?
These are worlds that have had liquid oceans at some point in their history, have potentially had life at some point in their history, and continue to have their environment altered through meteorological processes of varying degrees of deadliness.
So let's talk about the water phase. We're familiar with the water here on Earth. When did this exist on Venus?
So Venus and Mars both, for roughly the first 3 billion years of their lives, were able to support liquid oceans in their low-lying areas. And what is amazing as we think about this is life here on Earth really began to evolve during those first 3 billion years. We didn't so much have anything that was more than like single-celled and squishy, but we had life in those first 3 billion years. And if it was only as they neared, 2 billion years ago, that they became utterly inhospitable, there's the potential that those early oceans contained meteorites. Not meteorites, contained microbes. And this gets to the whole idea, though, of why did they both die? And the diverging history of these three worlds gives us a new view that we didn't even imagine last time we talked about these worlds, on just how the Goldilocks problem isn't a problem for today, it's a problem for how things evolved over time.
Okay, so why did Venus die?
Venus, as near as we can tell, had a massive runaway greenhouse effect. And depending on what papers you read, it was either several 100 million years ago to billions of years ago. And that runaway greenhouse effect that was driven by a change in chemistry, potentially by sudden volcanism across the entire world, or by ongoing volcanism that destroyed the planet a little more slowly. However you destroyed the environment, it was a greenhouse environment that thickened the environment, thickened that atmosphere. And as it got thicker, it trapped the heat in. Sunlight comes in, infrared radiation comes off the soil, and then just bounces around.
Do we think the volcanism happened first or the runaway greenhouse happened first?
The papers that I trust most have the two things being interrelated, where for unexplainable reasons, Venus sat there building up heat, and then just either flipped its surface in mass volcanism across the entire world, or had a massive epoch of volcanism that has continued across the planet, resurfacing the entire world over the past hundreds of millions of years.
I mean, here on Earth, we have the carbon cycle. We have the plate tectonics that shift the surface of the Earth around, and as carbon dioxide is generated on the surface, it gets sequestered. It goes underneath the plates and disappears out of the atmosphere and out of the surface environment. And we don't see that on Venus. We don't see any plate tectonics on Venus. So I guess same question, right? Did Venus's heat shut down its plate tectonics, or did its lack of plate tectonics drive its heat?
And this is something we don't know. And
yeah,
one of the problems is we haven't been able to get anything to live on its surface, robot-wise, long enough to go looking for earthquakes. And so while there are hints in research of areas called coronae, crowns, that look like recent volcanic activity, we can't measure the earthquakes, Venus quakes, I guess, that would either be caused by ongoing volcanism or would allow us to trace out the existence of plates. We can't do either. So we assume Venus doesn't have plates. We don't know if it has active volcanism. What we do know is some horrible point in its past built up too much heat in its atmosphere, evaporated all of the water, which became a new greenhouse gas, caused deadly acidic chemistry to take place, and potentially created a place where life can only exist in the clouds. And that idea just refuses to go away. There could still be life on Venus in the clouds. There are a variety of researchers that think the dark patches that get seen in its clouds periodically may actually be the aerosolized version of an algae bloom. But we don't know, but we're going to send 3 spacecraft there and hopefully find out.
Yeah, and I guess that was my point, or that I was about to make, was that we have 3 separate spacecraft that are going. That Venus is chronically, tragically underexplored. Mars is crawling with robots, but Venus, we haven't had a serious mission to Venus. There's the Akatsuki, the Venus Express, and then like Magellan in 98. So it's been a long time, and we haven't had a really serious, and attempts to land on the surface was like in the mid 80s. So it's time to go back to Venus for real, bring the modern equipment, and get to the bottom of these mysteries.
And it's just that much harder to go someplace it's warm. And the thing that brings this home to me is when I'm out gardening in the summer, if I set my iPhone down in the sun, it ceases to function in 20 minutes flat or less. But in the winter, if I do the exact same thing, my phone's like, I'm cold, you're going to run out of battery fast, but I'm not going to give you any big warning messages and die until the battery goes.
Right.
And the difference between having to figure out how to shed heat, which is hard, versus trying to figure out how to prevent your batteries from dying in the cold. Generating heat is easy. makes a world of difference between Mars and Venus.
All right. Well, we're going to talk about why Mars died in a second, but it's time for another break. And we're back. All right. I wouldn't say we know why Venus died. we, we, we have a series of interrelated complexities that may have contributed to the death of Venus. Answer waiting for spacecraft to arrive. What killed Mars?
Well, with Mars, it lacked the ability to hold on to its atmosphere. So Venus died because its atmosphere got thicker and thicker and thicker and thicker, and chemistry and death. On Mars, early on, its atmosphere was somewhat maintained by the fact that it had a repository of materials, ices, oceans, all of that formed an atmosphere, could sublimate, evaporate into being an atmosphere. But over time, the sun and lack of gravity and lack of a magnetic field that made the sun's effects greater, it just slowly pushed it away. And it continues to do so. If hydrogen or helium is released into our atmosphere, it's gone very quickly. If you release pretty much anything into Mars' atmosphere, it's gone pretty quickly. And here on Earth, the reason we lose hydrogen and helium so fast is it'll get hit by an oxygen molecule, nitrogen molecule, and that transfer of momentum sends it away at escape velocities. Without a strong magnetic field, pretty much anything you put into Mars' atmosphere, it's going to get eventually affected by the solar wind and blown away at escape velocities.
Although it is kind of interesting that the story of Mars water, I mean, that was definitely the understanding, was that all the water on Mars had evaporated and gotten broken up and pushed out, using this by the sun solar wind. But it does appear now that a lot of Mars's water went into the planet, got absorbed by the rock underneath, and there might actually have larger sources of water under the surface than we originally thought.
And this is where the key word is the surface water capable of
Right.
sublimating into the atmosphere. That's what went away. There is tantalizing evidence of dust-covered buried glaciers, of subsurface brines. And every month it seems like there's a new press release on new evidence of water at more equatorial radii than ever before. And it's a world that just might have ice we can access, and potentially even vast amounts at that massive trench shown in the image here, along the bottom of that trench, where the atmosphere is the thickest it is anywhere on Mars. And so here you have the largest canyon in the solar system, with not enough air to breathe, but more than elsewhere, and potentially water and protection from a whole lot of radiation all down at the bottom of that canyon.
Yeah, we talked about this last or 2 weeks ago with the 2021 show, that I thought this was one of the biggest stories of the year. And hopefully we'll see a lot more exploration and information about this, that the water on Mars could be tantalizingly close, easy to access, and could be a total game changer, both in the search for life, but also just in the support of exploration of the planet. I want to shift gears in a second, but it's time for another break.
You going to Earth?
Well, yeah, so I want to talk about Earth, but I also just want to talk about, we asked what killed those two planets. What killed Earth? Us. All right, moving on. But I want to know, I guess I want to put this in context for how we feel about terrestrial planets in general, as we think about this in the context of extrasolar planets. What is this starting to tell us? What are we starting to think about what we're going to find as we look around the rest of the galaxy, both what we know about Earth and what we know about Venus and Mars?
I think instead of viewing planets as following some Goldilocks scenario of this one's too hot, this one's too cold, this one's just right, it is much more like an avocado, where it's too hard, too hard, too hard, perfect, mush. And
Right.
and so you have this moment, and that moment is different depending on which avocado or which planet you look at. And it's how long a world is habitable that is really the question. That we can have all sorts of different scenarios where right now something evolving fast enough could exist. But if you wait, even our world is going to become no longer habitable. And so the question becomes, how big is the window? And it's the worlds with the biggest window, the biggest period of being not too hard and not too mushy. That's the exciting time to find them, and we're still figuring out what is that window for different kinds of worlds.
I mean, what does it look like? I mean, where would we find the best chance of picking up an avocado in the store, in an exoplanetary sense, and it being ready to spread on your avocado toast?
Well, there's some really cool research that just came out in the past, I want to say in the past week, that was looking at a new way of simulating solar systems, where they added into their simulations the difference in pressure you have in the disk around a star at the different places where materials change phase. So you're going to get this change in pressure at that point where water suddenly goes from being water vapor to being water ice. You're going to get a change in pressure at that point where silica suddenly is able to either vaporize or solidify. And a star like our sun creates planets at the places our solar system created planets, given the fullness of time and that temperature distribution through the early disk. And so if that person's right, and never believe a planet formation model, but I like this one because it actually reproduced our solar system.
Right.
If this is right, then to get the distribution of planets we see, you have to have the temperature profile that we have. And so the question becomes, and I'm guessing these simulations still need to be run, what other temperatures end up with the pressure boundaries just right, that in the fullness of time, with everything evolving, moving around over time, do you end up with planets at that, I'm not going to say magical, I'm not going to say golden, I'm going to say, what was that?
Habitable, Goldilocks.
Yeah, it's
just right.
Well, in that sweet spot, I guess that's the best word I can come up with.
Yeah.
That ends up with planets in that sweet spot where they are the right size to be able to generate a magnetic field and not cool off too fast, where they don't get hit so much that they end up with the rotation getting slowed down and ending their magnetic field early, which probably happened to Venus. They have that sweet spot where they're able to hold on to the magnetic field, have enough heat, and are able to have and hold on to an atmosphere long enough to evolve life.
But this sounds like you're throwing in a lot more variables. Is this constraining the size of a habitable zone for an extrasolar planetary system? Like narrowing the size of it to where you get those pressure gradients? Or is it just that it also depends on the chemistry of the planets, the size, the magnetosphere, etc.? What would be habitable to Mars-sized planets might be different than what's habitable to Earth or Venus-sized planets.
And then we also get down to the life as we know it versus life that's living beneath a shell of ice. So when we look at strictly the Goldilocks scenario of Mars, Earth, Venus, there we're starting to say, okay, so you're able to get planets cropping up at these places that have these experiences if you have a sun-like star with this temperature profile. We would have to rerun all the scenarios to see what do you get with bigger and larger stars, and can you get a similar outcome with different distances? And then, yeah, chemistry is part of that, because depending on the chemistry, things glom together in different ways, and you may or may not have enough stuff to form big rocky worlds. So I guess what I'm getting at is one really awesome paper published one really awesome way to actually explain how we got our solar system, and we're a long way from figuring out other solar systems. More computer time, please.
Yeah. But it's always going back to that question, right? Are we normal? Because we're wonderful. And I'm talking about that in the solar system sense. The fact that we have a planet, that blue planet with life covering it in this corner of the Milky Way is phenomenal. And we see horrible hellscape Venus to the left of us and awful, cold, frigid, dusty Mars to the right of us. And yet we're doing great. And I think the question still, like, we know of thousands of planets, but the question that just really hangs over us is that, were there 1,000 variables that all had to come together to make Earth the kind of planet that it is, or did it just take one or two fairly common situations to happen? And as we explore, and as the tools come online for us to explore these other planets, will we realize that Earth is extra special as opposed to just regular special?
And this is where I think back to when I was learning to solve the quadratic equation, and there were annoyingly 2 possible answers. And yes, there are probably far more than thousands of variables that go into it that all have to line up just right to get our world. But then there may be a different solution. There may be infinite different solutions that can get to other forms of habitable.
And that it could be like a steady state that the universe reaches, like the variables all could play together and get you to this standard point all the time. There
was another paper you probably saw that came out this week that talked about how the history of supernova explosions near our solar system affected our world's ability to have life, because the ionizing radiation of the supernovae generated greater cloud cover and affected the temperature history of our world. It's not
so,
just
could you not have life without a whole bunch of supernova going off at the right times nearby? Like, that just gets extreme at this point.
So we are just starting to know how many variables we have to figure out, and we haven't figured out all the variables, and we certainly haven't figured out the values of all the variables. We just know we have life here for now. Mars and Venus could have had life, may still have life as we do not know it. And that's amazing.
If you switch, what do you think? If you switched Mars and Venus in their orbits, do you think that would make a difference for either one of them? Would Venus be more habitable? I mean, Mars, I think, would be ruined either way.
Yeah, Mars is ruined either way. That lack of a magnetic field. So, Venus, if it hadn't had the bejesus knocked out of it by whatever changed its rotation to be counter to the direction you would expect, so that its days are longer than its years, I feel like playing with its rotation rate would get you a long ways as well. So the question becomes, how much do you have to change the day-night cycle, and where do you need to put it to rescue it?
Right.
Magnetic fields.
Fascinating. Yeah, absolutely fascinating. All right, well, thank you, Pamela.
Thank you.
Right, do you have some names for us?
I do. So, as always, our show is brought to you by you. We are immensely grateful to all of you who are part of our Patreon community and to those of you who have become one-time donors through PayPal. Now, those of you who have made the one-time donations, I love you. You are amazing. But the Patreons' names I get to read right now. So I'm going to go ahead and read some of our Patreons. Andrew Stevenson, Benjamin Davies, Glenn McDavid, Stephen Coffey, Elad Avron, The Mysterious Mark, Jen Greenwald, Smansky, Kinsiaya Pinflienko, Joe Wilkinson, Planetar, Sean Freeman, and Blexa the Cat, Peter, Roland Warmerdam, Dean, John Ushef, The Air Major, Sabra Lark, Brian Kelby, Arctic Fox, Claudio Mastriani, Aaron Tannenbaum, Bart Flaherty, Corrine Duptruck, Nalia, Tim Garish, Lou Zealand, Jordan Turner, Ray Venning, Alan Price, Mark, or that could be Alan Price, Mark Van Coy, Leah Harborn, Mark Phillips, Kathleen Matson, Bob the Cat, Chris Wheelwright, Jason Kerdalkas, Olivia Brian Zank, Ron Thorson, Papa 1062, Robert Hundy, Kim Barron Vitali, Paul Esposita, Arthur Latzhall, Scott Briggs, Reuben McCarthy, Umu, Jeff McDonald, Wayne Johnson, and Iggy Hammock. And if I've mispronounced your name, I'm very sorry. You can like change your Patreon username to be phonetically spelled, and I'll do better. I promise. Thank you.
All right. Thanks, everyone. Thanks, Pamela.
Bye-bye. And then they saved. I sometimes feel like a crazy person with how much I think there could be life on other worlds. And then I read all of these research papers that are written by like consortiums of global groups of astronomers. They're like, yeah, there could be life all over our solar system. And it's just like, okay, at least we have a shared delusion.
Yeah. Yeah. Oops. I'm gonna mess this up. Sorry. Yeah, I mean, I think there could be life across the solar system, but it's such a low energy environment that it would pretty much just be it exists. As
oh, I'm
opposed
not
to
looking for exciting life.
Yeah. I mean, we know for certain that the only place that's really kicking is Earth.
Yeah.
Which is too bad.
Well, it could be kicking around deep sea vents on Europa, because that's a long-term thermal environment. But
there just isn't a lot of energy. There isn't a lot of space and energy in the environment to be able to support any really significant ecosystem. And so that means that you probably won't get fairly large, fairly complicated creatures.
I just want a sea cucumber.
Oh, yeah. I mean, so we want a European space whale, but what we will probably get is sludge. We will get cyanobacteria, but European cyanobacteria.
I hold my heart out.
Cyanobacteria.
I want sea cucumbers. I may not be given sea cucumbers.
No, a sea cucumber is a lot of creature. So that's the. I mean, you know, there's some interesting papers that we've read and covered. Just this idea that just the amount of energy available.
Yeah.
To under the ice from these deep sea vents.
Yeah.
Is a fraction of a fraction of a fraction of what's available to the surface of the Earth thanks to the sun. I mean, the sun,
right.
Every square meter of the Earth is being hit by something like 1,000 watts of energy, while under the sea, you've got these tiny little zones where you could have some net energy going on. And same thing here on Earth. You know, we've got these places, but it just doesn't hold a candle to what it's like to be on the surface of a terrestrial world.
And
because people need to just, you know, manage their expectations for how creative life can get when it's starving all the time.
and the thing we have to remember is and I hate remembering this, The thing that we have to remind ourselves to remember is while there's the potential to have deep sea vents that are very, very similar to Earth's deep sea vents, Earth's deep sea vents are constantly being fed nutrients from higher up in the water column.
Yeah. Yeah.
So there's that.
Yeah, exactly. So you've got a serious lack of nutrients, of essentially the building blocks for these life forms to be able to make their bodies, and you've got a lack of energy gradient that they can get access to. So really the only place that you can really get a lot done is within a few hundred meters of a deep sea vent. And who knows how many of those exist on a place like Europa or Enceladus or whatever. So the potential is there, and it almost feels inevitable that life panspermia wise has gotten around the solar system.
Yeah.
But the amount of, like, you would have, it'd be interesting. I go dig up those papers again, but try to figure out like how much, like, would the total, if you took the life potential on Europa and transplanted it to Earth, would it be like the size of Manhattan? The entire world of Europa. How much space could be interesting? And it's not a lot, which sucks. But there could be 1,000 times as many worlds that have this kind of life than across the Milky Way.
And we are limiting ourselves to thinking about metabolisms on timescales that we're used to thinking.
Mm-hmm. Yeah.
They just found life a couple miles down in Antarctica that they weren't expecting to find. And Pluto, if Adine Denton's research is right, has a volume of liquid water equivalent to the volume we know life occupies here on Earth.
Mm.
Yeah. Order of magnitude.
Right.
So,
and
yeah.
Yeah, and I mean the speed, I think you're exactly right, that you could have life go incredibly slowly. I heard someone say like a tree, like a sequoia tree, is the most lived creature, like the creature that even though its clock cycle as a life form is slower than a mouse, it gets in so many of those cell refreshes that in fact it is the most lived creature that we have, and could very well be the most intelligent creature that we have
for various definitions.
Yeah, depending on the definition. Yeah, exactly. Just on how much, like if you define just like how much cell activity is going on over the course of a life form over the course of its lifetime, a giant tree with a lot of mass in it actually lives a lot of life. And so very well you could imagine things on Pluto doing that.
And then I think about the Greenland sharks, that there are individual sharks older than our country. Like older than white people have been since the Vikings in North America. And they have such slow metabolisms. So we have these cold, slow evolving or slow metabolizing creatures.
Yeah, I think that's a perfect model to the way to think about it. So, very cool. All right, we should take some questions.
Yeah, I should open Twitch back up. There it is.
Yeah. All right. Larry Beckham asks, "Was Venus ever alive? In what sense?" So, what do you think? Do you think?
Yeah.
Do you think Venus was Earth-like?
So there's research papers saying that Earth and Venus had comparable environments for the first several billion years, and that they were still comparable environments at the point that microbes were beginning to evolve on the planet Earth. So yeah.
And again, I'm a big fan of the panspermia idea. And so just this idea that life could have been transported back and forth from Earth to Venus.
Yes.
or from Mars to Venus to Earth, etc.,
Yeah.
is pretty exciting. And if Venus really was comparable, wet, a reasonable temperature,
Yeah.
access to nutrients, it could have gotten pretty far along. God, we got to go back to Venus.
Yes. Well, we're working on it.
I know.
Patience.
Hurry.
This is not a
Hurry.
field for instant gratification.
I wonder what it would take to try to get a sense of its like historical habitability. What would you be looking for?
So the concern with Venus in terms of looking for past life is that sucker had a lot of volcanoes that rewrote the history of its surface. And so there's no, what's that really old shale in the Canadian Shield. There's no Canadian Shield on Venus that we know of. There's no west coast of Australia that's super old. And with a world that's completely rewritten its surface, it's unlikely we'll ever be able to probe its past except through computer simulations.
Yeah. I mean, on Earth, a lot of ancient things that have happened are hidden because of the weathering.
Yeah.
But on Venus, it's hidden because at some point the planet turned itself inside out.
Yes. And
what a way to obscure your history.
Yeah. We at least keep bits and pieces stored away here and there. They don't.
Yeah. I wonder would that have happened quickly? Would it have happened slowly? How long would it have taken to go from things are kind of normal to everything's lava? The floor is lava worldwide.
So it depends on which paper you read. What gets me is our own planet Earth with the Siberian traps kind of went, and now this entire half a continent shall be lava. Mm-hmm. So we know these things happen here.
Not at the same scale, though.
No, just smaller scale.
Yeah.
Massive environmental damage. Just didn't destroy our world.
Yeah. So I don't see any questions. I guess we'll wrap this up then. We'll just shut it down. Or we'll talk about the weather. Or we'll talk about science fiction books that we're reading.
What are you reading?
I'm reading the Ian Banks series, the Culture series.
I'm actually reading the exact same books.
Really? Okay.
Yes.
So I just finished The Player of Games. Did you just read, or are you reading Consider Plebius?
I'm on book 1. I don't remember its title, but there is a massive game involved.
Consider Plebius.
Yes, I'm reading Consider Plebius.
Yeah. Plebius, yeah. The second one is called Player of Games, and so the whole series, as I understand it, it was about the culture, which is the society. But the first book is by somebody about somebody who's outside the culture, kind of an enemy to the culture, and so you see the culture tangentially. But in the second book and the rest of them, you're seeing it from the point of view of people inside the culture. And the Player of Games was so good. It was just a wonderful, wonderful book. I started to see where it was going and what was going to happen, but not entirely. But it was tight, and it was so entertaining. But it did have a massive game, so I'm wondering if that's the one that you read. But you would know if it was the one you read. But anyway,
yeah, no. I'm reading the.
Where the guy's chasing after an artificial intelligence, a spaceship artificial intelligence.
Yeah, and then at one point there's the weird card game with emotions.
Yes, and he's like on some planet participating in some gladiatorial thing. Yeah.
I'm just at the end of that.
Good. Okay. Yeah. But Consider Plebius was fun, but it was sort of a rough go.
Yeah.
Player of Games is silky smooth. It just goes down so nice.
Yes. I just wanted to start at the beginning.
Yeah. Jay Clooney is asking, did I miss the discussion on James Webb?
Stay tuned. Future episode. So Astroby London asks, is it practical that pieces of Venus could have been knocked off and landed on Earth? Yes, this has probably happened. Small pieces.
The only issue is just that both Venus and Earth have gigantic gravity wells compared to Mars. And so the mechanism that they think is most likely is that we find meteorites from Mars and Vesta. We don't find and the moon, but we don't find meteorites from Venus.
And we also don't find meteorites that struck the Earth billions of years ago. And right now, Venus has such a thick atmosphere that we're not going to, in all likelihood, get new chunks of Venus sent our way, because you have to have something go through the atmosphere, still have enough energy when it hits the surface that it can send chunks out at an escape velocity that doesn't just take into account the gravity well of Venus, but also the drag of that atmosphere. So having the atmosphere it has makes it harder for modern Venus to fling rocks at us. Past Venus didn't have that problem. So,
the one hope, the one piece of hope is, I don't know if you saw this, it was about a year ago or so, they found in one of the Apollo samples a chunk of the Earth in the moon that had been stuck in the moon. And so the thinking was that a giant meteorite hit the Earth, scooped up a chunk of debris, threw it out into lunar orbit. It fell on the moon. It got churned up with the moon with subsequent impacts. And so when the astronauts brought back a rock, the oldest piece of the Earth that's ever been found was found on the moon.
So Astro B makes the comment, surely the orbital dynamics would mean Venus material could not come out to Earth. Actually, no, it's fine. It's all a matter of energy. Just like we can send spacecraft on a single shot firing to Venus if we want to, Venus can send things back to us in a single shot.
It's just how much energy do they get?
Yeah, and there's a lot of luck involved. But in the fullness of time, enough things get launched in enough directions that these things happen.
Yeah, I mean, you think about something that's sent in a suborbital flight, or sent into it's hurled with enough velocity. I think it's more than about 12 kilometers per second, which then is escape velocity of the planet. But now you're in orbit, you're in solar orbit. And so you're going around the sun, and then you have a chance of interacting with the Earth. And you also have the solar radiation pushing on rocks over long periods of time that shift things around. You've got gravitational three-body interactions with other stuff. So there's a lot of opportunity for mayhem out there in the solar system. Joyful Running asks, big hypothetical question, if we found life in the clouds of Venus, could we maybe approximate a timeline via DNA studies, assuming the life uses DNA? It's a question for the Mars, I guess.
So it depends on how much DNA there is, and where we get messy is we are able to look at how many mutations have accumulated over time, and that gives us dating. And I don't know with Venus how we'd get past record. So if we found in the atmosphere of Venus something that was clearly descended from Earth life, then we could figure out the mutations. Right. I don't think we have anything that we could do that straight shot genetic mutation on, but that's how we figure out the age of things.
But let's say someone delivers biologists a sample of clouds of Venus, and it contains bacteria in it, and it does have DNA. Would they be able to trace back to a common ancestor?
If they had samples from a sufficiently diverse population of microbes where they could see the genetic drift that had occurred across the entire population, they would be able to figure out how recent there was a common ancestor. So yeah, you can use genetic spread, I guess, genetic drift as seen in the spread in genetics across the population to figure out when the last common ancestor was.
And that's what you'll see. I mean, if we do find some kind of life on, say, Mars or Venus, then the astrobiologists will attempt to find out, is it even DNA based? Like,
Oh yeah,
is
that's
it
the easy part.
right? Yeah. Yeah.
But
Step one, is it life as we know it? And then step two is, okay, so if we sequence its DNA, then when did we share a common ancestor?
and you can end up with weird population effects. So if you go to a tiny volcanic island in the middle of the ocean and study the genetics of all the rats on that tiny island, you might date them back to a ship that crashed there 100 years ago. And
Yeah.
rats have been on Earth for longer than 100 years, but by collecting populations of rats from a myriad of different places, and I'm using rats because ships spread them all over the planet. If you look at that diversity, you can find that the common ancestor for all of the rats is much further back in the past.
Renan BR says, any plans for more Venus missions? Feels like NASA ignored the planet.
There's
3.
3 new ones coming, 2 from the US, 1 from the European Space Agency.
And isn't Breakthrough doing one as well?
Yes, they're planning to do a small commercial one, but it's only going to be a couple of kilograms in size.
Yeah.
So
4.
4 kilograms in size.
No, 4 missions.
Oh, they're okay. So I didn't know they were doing 4 CanSats.
No. 1 from Europe, 2 from NASA, and 1 commercial one. 4 missions total.
Sorry. I'm just going to be confused. It's that point in a Friday. Yeah, I have to admit, I keep forgetting the Breakthrough one because I'm less excited because it's going to be like flinging your GoPro at Venus, which is cool. Like I would readily throw my GoPro at Venus if I could get images back from it. But the difference between flinging my GoPro and sending like the entire power of computation and cameras that are in my house at Venus.
Yep.
Yeah.
There's actually more than that. So the Indian Space Agency is going to be sending a mission in 2024.
Okay.
And the Russians have been working on their Venera D mission, and that's expected to go in 2029. So right now we're looking at probably 1, 2, 3, 4, 5, 6 missions, if you include the commercial one as well.
Okay.
Hello, dog. So 6 missions, but there's been a ton of other missions that have been proposed. At least another 5 or 6, mostly through NASA's NIAC series, and some really cool ideas. So
the coolest idea I ever heard was at a conference back in, I think, 2010 or 11, and it was presented by the Russians. And the idea was to send essentially a gazillion lawn darts at Venus that would have little tiny antennae. Only thing they'd have to really protect, and everything else would dig into the ground lawn dart style, and then they'd be able to essentially cover the world in small cheap sensors and figure out what was going on. And I loved that idea.
Yeah, that's really cool. Right. Sean asks, would it be possible to send a craft to the Venusian clouds, collect a sample, and return to Earth, or would that require too much energy?
It's possible. It would require too much money right now.
Yeah, I mean, I guess the question is, like, would you get a good sample if you tried to just do a flyby deep into the atmosphere? Like, you would definitely experience some atmospheric drag. You would definitely capture a sample, and then you would head back to space, and so that would require less than going down into the cloud tops and then sending a return vehicle. But I wonder if you would get a good sample.
So you'd probably want to have some sort of a compressor so you could get your sample and then compact it.
Mm-hmm.
But now you're bringing back a very dead sample. So,
Right.
I don't know. I don't know the best answer here.
Yeah. Yeah. I mean, I do like the idea. Like we've done, and by we, I mean NASA has done atmospheric entry using the atmosphere as a way to decelerate your spacecraft. Did that with some of the Mars missions, and so it would be pretty interesting to have a spacecraft do a fly through the atmosphere, but not deep enough to actually stop it. But then you would probably still need to fire your thrusters on the other side of the you would have lose some
Yeah.
velocity as you go through the atmosphere, and then you come out the other side, and then you would fire your thrusters again and use that as a way to kick yourself back to Earth. It's interesting. I like the idea.
Yeah. I feel
Yeah.
almost like you'd want to send two different missions with a slight offset in time where
Yeah.
the one dives through the atmosphere and then catches up with the other one as it goes past.
Yeah, interesting.
They're
Well, we've reached the end of our
dynamics.
hour, so it's time to shut it all down. So thank you, Pamela, for hanging out again this week, returning safely
Yes.
to another season, another several months of Astronomy Cast. Thank you to everyone watching us both on YouTube and on Twitch. Thanks to all the moderators for hanging out and helping out. And we'll see everybody next week.
Bye-bye,
Thanks for
everyone.